All right. Oops, that's the wrong one. So yesterday we started with analyzing graphs and finding all of the key things. We figured out where to find domain, range, which we look at our x values and y values from left to right. Maxes and mins, we just take just the y. For increasing, decreasing, and constant intervals, we do an interval of x values from left to right. And intercepts, we look at a point. Okay, so those are the key things that we're going to be looking at today. So we finished this, didn't we?
Yes.
We did. Okay, so we're going to go ahead and look at number 9. Okay, for number 9, Jane is riding in an elevator to the sky deck of the Willis Tower in Chicago. The function h of t models her height above the ground in meters. T minutes after she starts her ascent, the graph of h of t is shown. Okay, so we have everything we need here. We have our time in minutes. We have our height. These points and their coordinates tell us everything we need to know. And this coordinate is 0, 0. Okay, it gives us everything we need with those coordinates. So how long does it take for the elevator to reach the sky deck? What was that? 1 minute and 30 seconds, or 1.5 minutes. How high above ground is the sky deck of the Willis Tower? What was that? 412 meters. And we know that because our graph shows how high up the elevator takes them. All right, how long does Jane spend on the sky deck? 17 and a half is the total distance between elevator rides and everything. When she is actually up on the sky deck to when she leaves is what? 14.5 minutes. And we found that by doing 16 minus 1.5, which is 14.5. Okay, is the speed of the elevator the same going up as it is going down? Yeah. How do you know that? How long does it take the elevator to go up? 1.5 minutes. How long does it take the elevator to go down? 1.5 minutes. It's the same, okay? And we can see our slopes are the same as well. So it's the same time up as it is down. If you said something else, and as long as it has the same gist of that, you are good. When it has those explain questions, I will be looking to see how you explained it in your own words. I'm not going to look for you to regurgitate what you think I would have said. Okay? Do your best to explain what's happening. Okay, now we're going to look at number 10. So we are going to look at the complete graph of y is equal to f of x. And we're going to figure out when it's increasing, decreasing, or constant. Before we do anything, okay, increasing, decreasing, and constant, those are written as intervals of x. And when we write the intervals of x, it is going to go from the left to the right every single time. That is how we set those up, okay? So I'm going to just go through here and we're going to do each piece, and y'all are going to tell me if it's increasing, decreasing, or constant. What is this first piece of the graph doing? Increasing, okay? So if it is increasing, what is the x value where it starts increasing? -5. What is the x value it stops increasing? That's the y value. What's the x value there? 0. So from -5 to 0 is where we're increasing. The next part of our graph is doing what? Decreasing. And it will be 0 to what? 0 to 3. Because we use our x values. Okay, the next part of our graph is doing what? Increasing, decreasing, constant. Constant. How long is it constant? From what? 3 to 4. It is from 3 to 4. All right, now, the last piece of our graph is doing what? Decreasing. From 4 to 6. When we combine two intervals, what do I need to put between them? A union. So we'll go from 4 to 6. All right, now, the maximum value of f of x. This right here just wants the max y. That's all it's asking for. So what is the maximum of that graph? 6. So that is our answer. Yes?
Does it matter whether or not you use brackets or not?
So parentheses are what we have to use for increasing, decreasing, and constant. The reason being, at any given moment, we don't know if it's increasing or decreasing, okay? So like, the example I like to use is if we're watching Fast and the Furious, and it is zoomed in on their speedometer, and it's showing them speed up. It's showing them increase, right? If it pauses when it's looking at the speedometer, if the movie pauses, and it just says 72 on the speedometer, do you know if they're speeding up or slowing down? No. If it's just paused on that screen, you don't know. So at a singular point, it can't be included as increasing or decreasing. So we never use brackets, because brackets are only used when it's included. So we always use parentheses for increasing, decreasing, and constant, because we don't, at the ends of it, we could technically include 0 in the increasing side and in the decreasing side, right? So which one is it? Is it increasing or decreasing at 0? Do we know? We don't know. So we use parentheses. So because it can be either, so we use parentheses so it's not equal to. So we always use parentheses here for intervals of increasing, decreasing, or constant. We'll use brackets with domain and range, but not with increasing, decreasing, constant. Did that answer your question? All right. So the next question we're going to do is we're going to look at a question similar. We're going to look at a few questions similar to the graphing story questions on Delta Math. Okay? We're going to look at a graph and think about the context. So here we have the volume of water in a bathtub in gallons as a function of time elapsed in minutes is shown on the graph. Which description best matches the graph? Okay, so over here it shows we have our volume of gallons in the bathtub over our minutes. So that is what we're trying to get in context. A says the bathtub is full, then it is drained at a constant rate until it is half full, then it is filled again at the same rate until it is full. Is that what that picture is showing us? Is it showing us a bathtub that is full over here? No. Okay, so can it be A? All right. For B, the bathtub starts empty and is being filled at a constant rate. Once it is full, it is drained at the same rate. Is this bathtub starting empty? No. The bathtub starts half full and is being filled at a constant rate. Once it's full, it is drained at the same rate. Yes, that is what's happening. Our bathtub starts half full, it's filled up, and then it is drained. Okay, so it can't be D either. All right. We're going to look at these graphs over here. Same thing. We just figured out which graph fits better with the prompt. So Corinna is riding a horse on a carousel. Which graph best represents her distance from the center of the ride in a single rotation? Is it A or B? What was that? B. Why is it B? On a carousel, you are not moving, right? It's just spinning in circles. Like, you're not getting further from the center. It's just you are riding around the center on like it's It's like you're here and you're just going around the circle, right? That's what's happening on a carousel. You're actually not moving your distance. All right, now we have 13. A cup of hot coffee cools down to room temperature. Which graph best represents the temperature of the coffee, A or B? B. It starts off hot, it hits room temperature, and then it's going to stay room temperature. It won't get any cooler than that. All right, now 14, I need you to pay attention to the question, okay? Mitch went for a hike. He got halfway up the mountain and realized he had dropped his compass. He found his compass at the point which he had started his hike. He picked it up and then hiked to the top. Which graph represents the total distance? Total distance he walked, not elevation, just distance. It's just the total distance. It is A. Okay? So B would be perfect if instead of distance, that said elevation. Because he started at the base of the mountain. He walked halfway up, went, oh crap, I forgot my compass. Where is it? Walked back down, found the compass, then hiked to the top of the mountain. Right? Whereas over here, when he is doing all of this, he is still hiking. He is still walking a distance, right? It's like if you're running a suicide at practice. Okay, do y'all know what that is? Where you have to run from here to here, come back, then go to here, come back, here to here, come back. Have y'all ever had to do that? Awful, right? When you're doing that, when you go from here to here, you have a distance of, let's say, 5 feet, okay? When you loop back, how far have you then gone? Yeah, if you run there and then run back, how far have you went? Have you only went, how far have you went? If it's 5 feet there and 5 feet back, how far have you ran? 10 feet, right? Okay, each time he's going there and back, he's still walking a distance, right? It doesn't matter. So his distance is continually increasing. Because even though he is walking back down the mountain, he is still walking down the mountain, right? He is still walking a distance. If you're in a car and you drive up a mountain and drive back down it, does your mile tracker go up and then subtract miles? No, it keeps adding miles, right? It keeps adding it. So anytime you're doing that, the total distance is still going up. But if it was asking about elevation, B would be the correct answer. All right, so we have an assignment for the rest of class today. We're going to look at 3.3 and do some more practice. I'm going to pass it out. As soon as you get it, I want you to start working on question 1. Y'all don't need y'all's computers for this. You don't need your computer for this.
Oh, I'm not good with drawing. It's weird. You'll be fine. No, I'm not doing it.
I skipped y'all. All right. Once you have your paper, start working on number 1. Yes.
Does it matter what number we put in the front?
Yes. Okay. It has to go from left to right. It's the line in between 4 and 6, so it's 5. It counts by 2. It doesn't put 1, 2, 3, 4, 5 on there, but it counts by 2s. All right, for these, okay, this is what you should have as your answers. I would accept 2 different things for B. So, decreasing, if you show that it decreases from -12 to -8 and then from -8 to 0, that's fine. Technically, this entire thing is decreasing and it never stops decreasing, so you could also say from -12 to 0 because it's not being broken up by any other types of intervals. So, like, as long as you don't break it up with like a constant or break it up with an increasing section, you can just do the whole thing as decreasing. If it's just going from decreasing to decreasing, you're good. But I would accept either of those. Increasing from 0 to 5, because it is right there. And on this graph, that is in between 4 and 6. Then constant from 5 to 12 to finish it out. And our minimum value of f of x, that's our minimum y. What's our lowest y on that graph? -6. It is right here. Okay, so that is 1. I want us to look at 2 together. Okay, so for question 2, it is asking us to sketch a graph. Okay, whenever we sketch a graph, we are doing a rough drawing of it. It will not be exact. I am not grading it for exactness. I am grading it to make sure you met the given requirements, okay? Not for like it has to be a very specific thing. You are doing a sketch. It is going to be a rough estimate. So first, it asks you to sketch the graph of a function that is decreasing for x is less than or equal to -2. So when x is less than -2, does that graph need to go up or down? Down. So we're going to draw a line that goes down till x is equal to -2. Anywhere. I could draw it like that, or I could draw it like that. Anywhere that it is decreasing till it gets to -2, we're good. Does not matter where. It just has to decrease till it gets to x is -2. Okay, remember, we are looking at x values there, okay? So we're going based off of our x-axis. Then after that, we have to draw a line that is constant from -2 to 1. Okay, constant means what type of line? Straight line. So from -2 to 1, we're going to do a straight line, a straight horizontal line. Remember, we're using the x-axis of where to go for these. Okay, then we have, it's going to be increasing from 1 to 3. So between 1 and 3, does my line need to go up and down? It can go up to here. It can go up to here. It can go up here. It can go to just here. I do not care. As long as it is going up, you are good. Okay, and it is based off where the x values are. Then the last section says it is going to decrease for x greater than 3. Okay, it is going to increase for x is greater than 3. Or decrease, my bad. So decrease, that means it needs to go where? Down. Does it tell you where it needs to stop? So if it doesn't tell you where it needs to stop, you put an arrow to send it to infinity. Then we are going to look at question 3. Question 3 is one of those graph stories problems. I took it directly from Delta Math, okay? Because I want us to talk about it. These problems are great for making us think about graphs in context, okay? They're great for that, and we need to get our context stuff down. So During a snowstorm, Anna tracked the amount of snow on the ground. When the storm began, there were 3 inches of snow on the ground. So when the storm began, there are 3 inches of snow on the ground. So at 0, where do I need to put a point? 3. Okay? Then, the snow fell at a constant rate of 1 inch per hour until another 2 inches had fallen. So 1 inch per hour is our slope. That means our slope is just going to be 1 until 2 inches have fallen. So I'm going to go up 1 over 1, up 1 over 1. And draw that. Because the graph is really big. Because I screenshotted it directly from Delta Math. So. Okay. Then, the storm stopped for 6 hours. So what does that tell us we need to have? A straight line for 6 hours. So 1, 2, 3, 4, 5, 6. And then it started up again at a constant rate of 2 inches per hour. What will that make the slope need to be? 2 over 1. For the next 2 hours. So we're going to go up 2 over 1 for 1 hour, up 2 over 1 for 2 hours. And draw our line. So that is the graph of the inches of snow over the ground that Anna collected. Okay? That is it. That's all we have to do. It just wants us to sketch it out. We're going to sketch out exactly what it tells us in the prompt. If you haven't done that part of the Delta Math, go back and do that. Okay? Now that we've done an example, I want you to look at it. So, from here, we are going to do one last example, number 4, and then y'all are going to finish up this assignment. So, for question 4, the temperature of a small town in Missouri can be modeled by the function m, where m of t is the temperature in degrees Fahrenheit at t hours after midnight on a particular day. The graph of m is shown. Before we do anything else, our y-axis is our temperature. Our x-axis is our time. It is doing hours after midnight. It is counting up in military time, okay? For the sake of our understanding, we're going to put on there what times it is and like time that we use and understand. So this is 12 a.m. This would be 3 a.m., 6 a.m., 9 a.m., 12 p.m., that's noon. Then it's going to go to 3 p.m., 6 p.m., 9 p.m., and then it's going to loop back around to 12 a.m. till it gets a full 24 hours. Okay? That is what's happening there. It's just whenever we're doing an axis, we can't have it loop through numbers like that. It doesn't make sense. So that's why it uses the 0 to 24 instead. But you can answer it with these. So find the maximum temperature on this day. What is the maximum temperature on this day? 60 what? Yep. So the maximum temperature is 60 degrees Fahrenheit. And then it asks us, at what time does it occur? 3 p.m. At 3 p.m. You could also answer that after 15 hours. I'm good with either. Whichever one makes more sense, you can use. Okay. The next one says, find the minimum temperature on this day. What is the minimum temperature? 40. Not just 40, but 40 degrees Fahrenheit. And at what time does that occur? At 3 a.m. Or you could say after 3 hours. Either's fine. Okay. So then we're going to look at C. When is m of t increasing? So when does m of t increase? From 3 to when? 3 a.m. or 3 p.m.? Okay, from 3 a.m. to 3 p.m. It is increasing. So I have to write that as an interval though. When I do intervals, I use my x-axis. What do I need to put to make it match my x-axis? 3 to 15. And then it asks us to tell us this in context, okay? So that would be from 3 a.m. to 3 p.m. The temp is increasing. Why is the temperature increasing from 3 a.m. to 3 p.m.? What's happening? It's getting hot, but why is it getting hot? The sun's rising, okay? That is happening. The temperature is increasing with the sun. Now, it asks for question D, at what time or times in the day does the temperature that's supposed to be hit 50 degrees? How many times does it hit 50 degrees? Twice. Where are those at?
9 a.m.
9 a.m. and 9 p.m. All right. Then for E, is the temperature changing at a constant rate? No, it is not. Okay. How do you know that? What do you notice about?
It's not a straight line.
It's not a straight line, but what is the slope here the same as the slope here? No, it's a completely different slope, right? The only time you have a constant rate is if you have a perfectly straight line. If there is any curve to it, it's not constant. Okay, so this wouldn't have a constant slope, but this does. Okay, straight lines have constant stuff, curves don't. So no, the slope is changing. Now, you have two more questions. You have D and F, or F and G. Okay, it is on the back. You can't see your graph. So I'm going to keep this right here and I'm going to answer it while we're looking at the graph. Y'all can write the answer on the paper. So question F, or no, not question F. Oh, goodness gracious. Question F, yeah. It says, what is the appropriate domain for this function? So domain is our x's. So we have to use what is on our x-axis. Where does our x start? And it goes to 24. Okay. Are the dots at the end of this open or closed? Closed. It is always closed unless it shows an open circle. So we use brackets. Now, range. That is our y's. So it will be 40 to 60, and with brackets. Why is it not 10 and 80? Because it's not where the line's at, right? It's not the temperature in the day. It wasn't 10 degrees and 80 degrees in the same day. It was 40 to 60. Okay, so I want y'all to finish up questions 5 and 6 for me, okay? And then if you do not, y'all have about 10-ish minutes, about 10, 15 minutes to finish that up, those 2 questions, and then turn it in. If you don't finish, it's homework, okay?
What if you have like 3 points? Do you just keep doing the U thing?
Keep doing the U.
Remember the open circle or closed bracket?
Open circles, parentheses, closed circles, bracket.
Only when it's like
Yeah, only on domain and range. Intervals of increasing, decreasing, or constant are always parentheses. You can use the restroom.